Grounding, also known as earthing, is one of the most critical yet often overlooked elements of electrical safety, playing a direct role in protecting human life, electrical equipment, and entire power systems. At its core, grounding is the intentional connection of electrical systems and exposed conductive parts to the earth through a low-resistance path. The earth acts as a vast electrical sink that can safely absorb excess or fault current. Under normal operating conditions, grounding may appear inactive, but the moment a fault occurs, such as insulation breakdown, moisture ingress, or accidental contact between live conductors and metal enclosures, it becomes the primary safety mechanism. Electricity always seeks the path of least resistance, and without proper grounding, that path may pass through a human body, leading to severe electric shock or electrocution. Grounding prevents this by ensuring that fault current flows rapidly into the earth instead of through people or sensitive equipment. This rapid flow of current causes protective devices like circuit breakers, fuses, and residual current devices, RCDs, to detect abnormal conditions and disconnect the supply within milliseconds, drastically reducing the duration and severity of exposure. Beyond shock protection, grounding also plays a vital role in fire prevention. Fault currents that are not safely diverted can generate excessive heat at unintended points, gradually degrading insulation and igniting nearby combustible materials. Proper grounding stabilizes system voltage, limits overvoltages, and provides a discharge path for transient surges caused by lightning strikes or switching operations, which are common sources of electrical fires in both residential and industrial environments. In practical applications, grounding takes several forms, including equipment grounding, system grounding, and earth electrode grounding, each designed to address specific safety and operational requirements. In homes, grounding primarily protects occupants from electric shock by bonding appliance enclosures and metal conduits to earth. In industrial facilities, where high fault currents and complex machinery are common, grounding protects not only personnel but also expensive equipment, control systems, and instrumentation from damage and malfunction. However, grounding is only effective if it is properly designed, installed, and maintained. Common grounding failures, such as loose connections, corroded earth electrodes, high earth resistance, or undersized grounding conductors, can render the system ineffective, giving a false sense of safety while increasing risk. Regular inspection, testing of earth resistance, and compliance with electrical standards are essential to ensure grounding performs as intended. In modern electrical systems, grounding works hand in hand with bonding, which ensures that all exposed conductive parts remain at the same electrical potential.